NEC Article 310.15b6 addresses the proper methods for connecting conductors. It specifically prohibits connecting more than one stranded conductor to a single circuit breaker pole or terminal unless specific methods are employed. The core principle is to ensure a secure and reliable electrical connection, minimizing the risk of loose connections, overheating, and potential hazards. Dividing the strands of a conductor and using two holes on a neutral busbar is not permitted. This is because dividing the strands compromises the integrity of the conductor and reduces the effective contact area at each connection point. This can lead to increased resistance, heat generation, and ultimately, a potential fire hazard. When connecting two or more conductors, the NEC mandates the use of either a pressure wire connector or splicing with a twist joint and taping. Pressure wire connectors, also known as mechanical connectors, are designed to securely clamp multiple conductors together, providing a reliable electrical connection. These connectors come in various sizes and configurations to accommodate different conductor sizes and numbers of connections. They are typically made of metal and have screws or other mechanisms to tighten the conductors within the connector. When using pressure wire connectors, it is crucial to select the appropriate size and type for the conductors being connected. The connector must be rated for the voltage and amperage of the circuit, and it must be compatible with the conductor material such as copper or aluminum. Proper installation is essential to ensure a secure and reliable connection. The conductors should be stripped to the correct length and inserted fully into the connector. The screws or other tightening mechanisms should be tightened to the manufacturer's specified torque. Splicing with a twist joint and taping is another acceptable method for connecting two or more conductors. This method involves twisting the conductors together to create a mechanical connection and then insulating the connection with electrical tape. When splicing conductors, it is important to use the correct technique to ensure a strong and reliable connection. The conductors should be stripped to the correct length and twisted together tightly, ensuring that there are no loose strands. The trace should be long enough to provide adequate mechanical strength and electrical conductivity. After twisting the conductors together, the connection must be insulated with electrical tape. The tape should be wrapped tightly and evenly over the entire connection, overlapping each layer to provide a complete seal. The tape should be rated for the voltage and temperature of the circuit. It is important to note that splicing with a twist joint and taping is generally limited to smaller conductors, typically those used in residential and light commercial wiring. For larger conductors, pressure wire connectors are generally preferred due to their superior mechanical strength and reliability. In summary, NEC Article 310.15b6 prohibits dividing the strands of a stranded conductor and using two holes on a neutral busbar. Instead, the code requires the use of either a pressure wire connector or splicing with a twist joint and taping. These methods ensure a secure and reliable electrical connection, minimizing the risk of loose connections, overheating, and potential hazards. Always follow the manufacturer's instructions when installing pressure wire connectors and use the correct technique when splicing conductors. Adhering to these guidelines will help ensure the safety and reliability of electrical installations. It is very important to use a listed connector appropriately sized for the number and size of conductors in the connection. Wire size is measured in American wire gauge, or AUG. Common residential wire sizes are 14 AWG, 12 AWG, and 10 AWG for circuits rated at 15 amps, 20 amps, and 30 amps respectively. Larger appliances such as electric stoves, water heaters, and air conditioning units will use larger wire sizes such as 8 AWG, 6 AUG, or even larger depending on the amperage of the appliance. Commercial and industrial applications may use even larger wire sizes and may also use different types of conductors such as aluminum or copper-clad aluminum conductors. The size of the wire must be matched to the overcurrent protection, which is most commonly a circuit breaker. The circuit breaker is designed to trip and interrupt the flow of electricity in the event of an overcurrent or short circuit, thereby protecting the wiring and equipment connected to the circuit. Using a circuit breaker that is too large for the wire size can create a fire hazard, as the wire may overheat before the circuit breaker trips. Conversely, using a circuit breaker that is too small for the wire size can cause nuisance tripping, which is the unwanted interruption of the circuit. All electrical work should be performed by a qualified and licensed electrician to ensure that it is done safely and in accordance with all applicable codes and regulations. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent electrical shock and fire. Always turn off the power to the circuit before working on it, and use appropriate safety equipment such as insulated gloves and tools. If you are not comfortable working on electrical systems, it is best to call a qualified electrician. Additionally, electrical systems should be inspected regularly to identify any potential problems, such as loose connections, damaged wiring, or overloaded circuits. Regular inspections can help prevent electrical fires and other hazards. It's also important to ensure that all electrical equipment is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Grounding is typically achieved by connecting the metal enclosures of electrical equipment to a grounding electrode, such as a ground rod or a metal water pipe. Grounding systems should be tested periodically to ensure that they are functioning properly. In summary, electrical safety is of utmost importance. Always follow all applicable codes and regulations, use appropriate safety equipment, and consult with a qualified electrician if you are not comfortable working on electrical systems. By taking these precautions, you can help prevent electrical shock, fires, and other hazards. Remember to only use appropriately rated tools and equipment. Always ensure the power is disconnected before working on electrical equipment. When disconnecting or reconnecting wires to any sort of electrical panel, first identify the circuit, switch the breaker or fuse off, and then use a calibrated meter to test the connections to ensure the power is actually off. Never rely on the labeling of a panel, as circuits may have been changed over the years. It's always better to double check and be safe. When working with conductors, never exceed the full capacity for any conduit or junction box. Exceeding the full capacity can cause conductors to overheat and cause a fire. Be sure to use the appropriate size and type of conduit or junction box for the application. The NEC provides tables for determining the full capacity of various types of conduit and junction boxes. These tables take into account the size and number of conductors, as well as the type of insulation. It's also important to ensure that the conduit or junction box is properly supported and secured. When running conductors through walls or ceilings, be sure to protect them from physical damage. This can be achieved by using conduit or by running the conductors through bored holes in the studs or joists. If the conductors are run through bored holes, they must be at least 1.25 inches from the edge of the framing member. If the conductors are closer than 1.25 inches to the edge of the framing member, they must be protected by a steel plate or sleeve. When making connections to electrical equipment, be sure to use the appropriate type of connector. There are many different types of connectors available, each designed for a specific purpose. Using the wrong type of connector can result in a loose connection, which can cause overheating and a potential fire hazard. It's also important to tighten the connectors to the proper torque. The manufacturer's instructions will specify the correct torque for each connector. Over-tightening the connectors can damage the conductors or the equipment, while under-tightening the connectors can result in a loose connection. When installing electrical equipment, be sure to follow the manufacturer's instructions. The manufacturer's instructions will provide detailed information on how to install the equipment safely and correctly. It's also important to ensure that the equipment is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. It's important to note that electrical codes and regulations can vary depending on the location. It's always best to consult with a qualified electrician to ensure that all electrical work is performed in accordance with the applicable codes and regulations. Electrical codes and regulations are constantly evolving to reflect new technologies and safety concerns. It's important to stay up to date on the latest changes to the codes and regulations to ensure that all electrical work is performed safely and correctly. Continuing education courses and industry publications can help electricians stay informed about the latest changes to the codes and regulations. The proper handling and installation of electrical equipment is key to ensuring a safe and reliable electrical system. Be sure to always follow all applicable codes and regulations, use appropriate safety equipment, and consult with a qualified electrician if you are not comfortable working on electrical systems.